Hello class. Today I'm going to go through the review sheet one problem at a time to help you if you need any sort of review for tomorrow's test. The first problem we have here is just evaluating a factorial problem. So on your calculator you would just put in 10 factorial over 10 minus 3 factorial and you should get an answer for that, but I'm just going to show you what the expansion would be. And that would be over 7 factorial, which that would cancel out with that, and you would have the equivalent of 10 times 9 times 8, which would be 720. The next one is 45 things taken 3 at a time, where order is important. So on your calculator you would do 45 NPR 3, and that would amount to 85,140. In the next problem, we want to see how many different ways the letters can be arranged for the word payment if we use 6 letters at a time. So that would be 7 to choose from. Order is important. So it's a permutation calculation, and we're only using 6 letters of 7. So that would amount to 5,040. In the next question, it says a signal is made by placing three flags, one above the other, on a flagpole. If there are seven different flags available, how many different signals can be flown? And that would be 7 to choose from, and we're looking for arrangements of 3, so that would be 7 NPR 3, which would equal 210 arrangements, or 210 different flags. How many different 3-numbered combinations, and notice they put combinations in quotations because we know that's incorrect, from having 26 numbers on a combination lock dial. So we would use 26 numbers to choose from, and we're going to do permutations of 3, and that would be equal to 15,600. On number 6, class of 14 students, we're going to have 5 A's, we're going to have 4 B's, 3 C's, 2 D's. So this is going to form a sequence of letters which will be 14 long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, if they were all different letters, we would have 14 factorial different combinations. But because we have repeats, 4 repeats, 3, because we have the repeats of 14 factorial, we have to divide out 5 repeats for the A's, 4 factorial for the B's, for the 4 repeats, 3 factorial, and so on. And that results in 2,522,520 different permutations. In number 7, they say, how many different ways can the word window be arranged? Well, we're going to use all 6 letters, and we've got to make sure we divide out the duplicate letter, which would be the W, as 2 factorial. So that would be the same as 6 factorial over 2 factorial, which would equal 360 arrangements. How many 7-card hands are possible with a 52-card deck? Well, this would be a combination because it doesn't matter the order in which you get the 7 cards. So that would be 52 NCR 6. I apologize, I meant to say 7, and that would be quite a few different combinations. So now we have a class of 25 girls and 33 boys. How many ways can you pick 2 boys and 2 girls to form a committee? Well, this is just picking out the number of ways to do this. This would be 25 girls to pick from, and you're going to pick them in groups of 2, and the order doesn't matter, so it's an NCR. And we'll multiply that by, we have 33 boys to pick from, and we'll take them 2 at a time. Multiplying the results gives you an answer of 158,400 combinations. A test contains 31 questions. You tell the student they must answer 28. It doesn't matter what order they answer them or the order of the questions. So that's a combination problem of 31 to choose from. Taken 28 at a time. And that is equal to 4,495 ways. And the next question, in how many ways can you make a team of 9 players out of 20? That's again another combination question. And that would be 167,960. On the next problem, the highest probability will be the event that occurs the most. So that would be event E, but you have to say what the probability would be. So I summed up all of the events, and then we had 500 total, and so 145 divided by 500 gives us a 29% chance of that event happening. On the next problem, on election day, turnout's expected to be 35%. If there are 6,000 people eligible to vote, how many people will cast their vote? You would just multiply 0.35 by 6,000, and that would tell you how many people are expected to turn out. And that would be 2,100 voters. On the next problem, we want to draw 4 queens from a deck of cards and any other card. So let's just figure out the total number, because it's probability. The total number of possibilities is we have a deck of 52, and we are picking 5 cards. Well, what we first have to consider is we're going to pick 4 queens, so we have 4 to pick from, and we want to pick all 4. And then for the next pick, it's any one card out of the 47 cards remaining, or 48 cards remaining. There would be 47 cards remaining. So NCR1. And that should give you the equivalent of 0.000180 probability. The next problem is a bit more simple. It says when the single card is drawn from a deck of 52, what's the probability of getting a red card? Well, there are 26 red cards for 52. So that would be a 1/2 probability. The next one says we have a bag of marbles, 7 red, 2 blue, 4 green. What's the probability of choosing a blue marble? When one marble is drawn, that should be pretty easy. We have 2 blue over 13 marbles total. So your probability would be 2 out of 13. The next problem says we have 2 dice, and what's the probability the sum of the numbers will be a 6? You want to draw a sample space for this one. So I'll draw that and I'll come back. I just drew sample space, and the numbers that will come up to be 6 will be along this diagonal. This is the first die, this is the second die, and if you look at it, you can see how we just added the row and column values to get what the sum would be. So we have 5 possible 6s out of 36 total, so the probability to get a sum of a 6 would be 5 in 36. The next problem deals with 6 cards that will be drawn from a deck of 52. We want to draw 4 spades and 2 hearts. So the probability of that happening would be, we're going to take 6 cards out of the deck, so that would be 50. Total possible combinations are 52 combinations of 6 in the denominator, and the numerator, the first part will be for the spades, which will be 13 NCR4, and for the hearts you would multiply that by 13 NCR2, and that should give you 429 over 156,604, which should give you a probability of, a decimal at least, of 429. Just be careful when you use your calculator to plug in the right values. So less than, well, actually 0.00273, that would be 0.2%, 0.273%. I hope this has been helpful, and we'll be having the test tomorrow, and if you have any questions, just email me or see me before the test tomorrow.